We're going to be looking at what's called the product rule and the quotient rule. So at this point, we've seen that the derivative of the sum was the sum of the derivatives. And that seemed, that's ideal. That makes things easy to calculate if you take derivatives, what we say as term-wise. Take the derivative of the first term, move on, take the derivative of the second term, move on, take the derivative of the third term, and that's straightforward. The same is not true for the derivatives of the products and the quotients. Okay? So I wish that if this would be an ideal world as far as difficulty goes, that if I said take the derivative of f times g, that it would just be the derivative of f times the derivative of g, where you would just take the derivative of each factor. But that is not the case. Okay? Instead, when you go to take the derivative, and you see what's happening here? I'm taking the derivative, so let's just mention this because you're still getting used to the notation. This d dx term, that means take the derivative of, and then whatever follows. Okay? So take the derivative of this product. You see it as a product? I've got some function. This could be e to the x times x cubed or something like that. It's two functions being multiplied together. So the product rule says we take the first times the derivative of the second plus the second function times the derivative of the first. Okay? That might look a little daunting. Here's a more compact way of writing it, sort of using the prime notation. So it's a more compact way of writing this. Absolutely, you have to have this derivative rule memorized. So here's how I remember it. Okay? By the way, there are other mnemonics out there. Some of you may have heard them. You can use your own mnemonic. If it was given to you by an approved math teacher, it's good to go. Okay? And it's probably right no matter. But I'm not going to check it for you to see if it's right. But this is what I remember. I say the first times the derivative of the second plus the second times the derivative of the first. Okay? So sometimes what you'll see me do is you'll write first times the derivative of the second plus the second times the derivative of the first. So for those of you who have seen this before, you might have a different ordering here. So let me just highlight to you how you can quickly tell whether somebody else who's doing it in a different order is doing it correctly. Notice I take each function and multiply it to the derivative of the other function, and then I add those up. Okay, so there's lots of ways I could order these four quantities, but you make sure that you take one of the functions, multiply it to the derivative of the other, and do the reverse of that. Add them up. Okay? So for the proof, and you might have noticed this, for the proof is on D2L. So please, tonight or tomorrow, preferably tonight, go home, watch the video for this proof, and just copy it into this space here. Okay? And that's mainly just, normally I would like to do that in front of you, but we're running out of time. So I'm trying to make up for some lost time. So let's put this into practice. Okay. As you recall, if I gave you the function h of x is equal to x cubed, just as a reminder, we can take its derivative now by our power rule. We'd have that its derivative is 3x squared, right? Okay. And if I had the function k of x is equal to e to the x, the exponential function, we've learned how to take its derivative. This was its own Kentucky cousin, right? The derivative of e to the x is e to the x. It's its own derivative. Okay? Any questions on that? Okay. All right, so remembering those two, let's go ahead and now all you have to do is memorize the product rule and put in the information you already know. So, f prime of x is equal to, what's my little mnemonic? You take the first function. What's the first function listed here? X cubed. By the way, let me just emphasize, do you see that this is a product here? The way I'm thinking about this is the function x cubed times the function e to the x. Okay? So it's the first times the derivative of the second. The derivative of e to the x, though, is e to the x. Plus the second times the derivative of the first. Okay? So again, I would recommend, until you've got this rule down pat, that you just write below it what you're doing. It's the first derivative of the second plus the second times the derivative of the first. Are there any questions on that? Okay. Let's do a couple of these. So we've got the function f of x is equal to x e to the x. So let's find df dx. Okay, again, I'm trying to use as much, I feel like you're probably all comfortable with the prime notation. So I'm just trying to make sure you see the other notations and get just as comfortable. This just says take the derivative of f with respect to x. Okay. Should we say that out loud? Let's say that out loud. Take the derivative of f with respect to x. Okay. So again, we've got a product rule. I have this factor, x, multiplied to this factor, e to the x. Okay, so this is going to be very similar to the last one. So here we go. We take the first times the derivative of the second plus the second times the derivative of the first. Okay, which I could clean up as x e to the x plus e to the x. I'm fine with you leaving it there, but notice that I could factor out an e to the x. So I could write this as x plus 1 e to the x. So either place is perfectly fine to leave your answer. I sort of feel like it's not asking a lot of you to simplify e to the x times 1. Okay. All right. So now that's the first derivative. Now I'm asking you to take the second derivative of f, again with respect to x. Okay. So that's equal to the derivative of let me put a bracket around that. X plus 1 e to the x. So in this case, we're going to think of this as the first function and e to the x as the second function. Okay. So I'd like you guys to try that in your groups. Okay. Take the derivative of that. And if you want, if you're feeling good, go ahead and factor it when you get down to the end and see what you get. Quiet in here. Check with your neighbor, see if you're on the right tracks.
Yeah, but that's because I already multiplied it in. And then I was like, oh, we'll take this.
That goes to 1 times x plus e to the x. So wouldn't it be 2? No, because the derivative of x is 1.
You're on the right track. Now you can go to distribute and select. Yeah. Yeah, except, yeah, exactly.
But then, is that what the process then?
All right, folks, it looks like you're nosing your way through it. Let's go ahead and take a look up here. So I've got a product rule. I'll go ahead and call this the first and this the second. So when I go to take the derivative of this, I'm going to get the first times the derivative of the second plus the second times the derivative of the first. Let me go ahead and write that derivative of the first. I normally don't do this, but just to kind of emphasize, make sure we're all on the same page, I'll write the derivative first as 1 plus 0. Okay? So again, until I get really, really good at this, I'm just going to go ahead and label things below. First, the second. Oops. The second plus the second, the first. Okay. This cleans up again fairly nicely. If I distribute this e to the x, I have x e to the x plus e to the x plus e to the x, which is the same thing as x e to the x plus 2 e to the x. And now if I factor out an e to the x, I get x plus 2 e to the x. Any questions on that? Okay. So I will let you on your own time check, but do you have a suspicion as to what this one will be? So this one's nice because you can check your work, right? So check your work, see, make sure you can get there. Okay. And so then what is this? Well, this is just kind of a fun extension. So the nth derivative, so I'm just saying arbitrarily, if we did the 20th derivative or 8th derivative, what will that come out to be? It would be what?
X plus n to e to the x.
X plus n e to the x, which is kind of nice. Okay. Questions on that? We're going to get a lot more practice with the product rule here in a little bit. But because tonight we're going through 3.4 and 3.5, well, we'll go ahead and practice this one. So, I just want to make sure we're all on the same page here. If I gave you the function g of x is equal to the square root of x, what is the derivative of that function? 1 over 2 root x. Okay, so I think it's a good idea to memorize that this is 1 over 2 root x. Just memorize it because we do it enough. But then let's say you forget. What can you do? What's that?
Put it to the 1/2 power.
Yeah, if we rewrite g of x as x to the 1/2 power, then what would be g prime of x? It would be 1/2 x to the minus 1/2, right? And so that would give us 1 over 2 square root of x. Okay? So this is how we get the derivative using our power rule. Okay? Of course, you could use the limit definition, and you did in section 3.2. You used the limit definition to find this derivative. Okay? But here's using the power rule to get there. But I think it is worth your time to just memorize this one because we use it so often. Okay? All right. So based on that, I've got this function here, f of x is equal to the product of the square root of x and a plus bt. Okay? Let's make sure we're all on the same page with this as well. I have one variable in this function. What is it? I have the variable t. I have two constants in this function. What are they? A and B. Okay? So the constants are considered fixed. The variables are treated as variables. It's just that the constants haven't been specified. Okay? All right. So we go to take the derivative of this. Right, f prime of t is equal to, so here's the first function, times what is the derivative of the second? What's the derivative of that second function? Right, so the constant term a, its derivative is 0, and the derivative of a linear term, b times t, is just the slope, b, right? So this is just b. So I'm going to go ahead and write it as 0 plus b, just to make sure we all see that. plus the second, a plus bt, times the derivative of the first, 1 over 2 square root of t. Okay. So we could clean that up a little bit. This would be b radical t plus a plus bt over 2 radical t. I am perfectly fine with parking this right here. Okay? I don't think it's worth our time to go ahead and combine this as a single fraction. My math lab will ask you to combine this as a single fraction. Okay? What's your denominator going to be? Yeah, the denominator would be 2 square root of t, right? Okay. All right. By the way, a lot of you are going to have questions. I'm perfectly fine with that, but I think tonight I'd like to, because we're trying to get through as much material as we can, I'd like to hold off on the question of, do you want me to simplify this more, or could I leave it here without simplifying to what you did? Let's just work through it tonight, and then what I'd like you to do is take a look at the practice exam, and you'll see a lot of my problems I say do not simplify, and if I don't say that, then I want you to simplify to the level that I'm doing. Okay? All right. So I'd like to kind of hold off on that question for tonight, but I will certainly address it on Wednesday when we review. Okay, next page. We just did the product rule, so now we do the quotient rule. Things get more complicated when you divide. That's fairly common in math. Okay. So here I'm saying take the derivative of the quotient of the functions f and g. Okay. By the way, I didn't add to this, and probably I should have, where g of x does not equal 0. I need to fix that for next time. So how do you do the derivative of the quotient? Okay. Well, here I've given you a little mnemonic. I say you take the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, that's a mnemonic to remember this. There are others. I've heard nursery rhymes like low d high, high d low, square the low, and there you go, I think. But I don't remember that. I find it harder to remember the mnemonic than to remember the rule. So I'll let you can search, you can ask your friends, hey, what do you do to remember this? But you need to come up with something to remember the quotient rule. Okay? All right. So let me just show you how mine works. If we call f the top and g the bottom, then we would have the bottom function times the derivative of the top minus the top function times the derivative of the bottom all over the bottom function squared. Okay? So proof, C_D_2L. I will have it up by the break, so if you want to go watch it during the break, you could even do that. Okay. But I've made the video, but I haven't quite gotten it uploaded yet. All right. So let's put this into practice. Okay. So I'll do this one with you, and then you guys can try 7 in your groups. Okay. So we're asked to find dy dx. The big picture, when I look at this, is I see a quotient. Okay. Sometimes, I'll say this now, sometimes you can rewrite a quotient another way so that you don't have to use the quotient rule. But I think this is definitely a problem where you do need to use the quotient rule. Okay. So I'm going to go ahead and call, let's call f of x equal to x squared plus x minus 2. Let's call that the top. And then let's call g of x equal to 2x plus 1. Let's call that the bottom. Okay. So how do I take the quotient, the derivative, excuse me, how do I take the derivative of a quotient? The quotient rule says I'm going to first take the bottom function. So I write that out. Here's the bottom function. 2x. Oops. How did I get that? Oh, I took the derivative. Excuse me. Sorry, folks. I've got taken derivatives on my brain. All right. So I'm going to take the bottom function, which is x cubed plus 6. So I'm looking at sorry to make you flip pages, but I'm looking at that mnemonic that says bottom times the derivative of the top. So there's the bottom function. What am I going to multiply it by? The derivative of the top, which would be 2x plus 1. There's where that shows up. Okay. So if you're following along with the bottom mnemonic, we've got the bottom times the derivative of the top minus what? The top times the derivative of the bottom. So we've got a minus sign from the formula. Be careful with that, minus sign from the formula. So minus the top, what is our top function? That's just x squared plus x minus 2 times the derivative of the bottom, which is what?
3x squared.
3x squared. I'll go ahead and put plus 0 here again because we're just getting comfortable with this rule. Okay. All over the bottom squared. So I'm just recopying this since I can't quickly flip back and forth. Okay. So this is all over, what was our bottom function? X cubed plus 6 squared. Now, I didn't in this problem say do not simplify, but for one like this, I would probably not have you simplify it on a test. Just because I'm interested in whether you know the quotient rule and not having you spend a lot of time rewriting stuff. It would not be unfair to ask you to simplify this, right? All you would have to do is FOIL this out, distribute this 3x squared, collect like terms, and then just double check you can't cancel a factor in the denominator, which you probably won't be able to. All right, in your groups now, I'd like you to do number 7. And if you get done with number 7, move on to number 8. Try to think of 2 ways to do number 8.
Yeah, you can totally simplify.
If you had to keep
Folks, are there any questions on number 7 here? Okay, double check. This is definitely one that you'll have to simplify in my math lab and it'll be a pain. Okay? I will not make you simplify this on an exam. Okay? Please, one thing I would encourage you to do is if you're getting hung up on the simplification in my math lab, just kind of take a breather, go work some other problems, and I think my math lab should tell you if you've got the same answer with just not in simplified form. If that's the case, I know we're working for the highest scores you can, but I would say that means you're on the right track. You're getting the calculus down, and that's the most important part. And then when you get some more time, worry about the simplification. All right, let's look at number 8 here. Okay. So the quotient rule is a very powerful rule, but it's also kind of clunky. Okay, so sometimes you can avoid using it. I'd like to do this first with the quotient rule, so we take d dx of 9 over x to the 5th. So using the quotient rule, I'd have the bottom times the derivative of the top. What's the derivative of the top here? 0, because it's a constant, right? Minus, don't forget that minus, it's often dropped. Okay. Minus the top times the derivative of the bottom. All over x to the 5th squared, right? You can say x, if you said x to the 10th, perfectly fine. So let's clean this up. I think this gives us minus 45 x to the 4th over x to the 10th, correct? But then I could simplify that one step further by writing that as x to the 6th power. Right? All right. So at this point, I need to know if I've lost anybody, because if I have, it's not your fault. I've not done my job. So what questions do you have? Yes?
Wait, so yeah, that's what I think where you got, and then I said it would be x negative 45 times x power of negative 6. You just hit the, since it's negative 6.
Yeah, so I do, so that is one thing, that is kind of a rule of mine. If the original problem has only positive exponents,
Yeah.
then I would like you to return it that way.
Okay, okay.
Yeah.
All right. Cool.
Yep. Okay. Other questions? Okay. Now here's I would not use the quotient rule on a problem like this. Okay. In fact, you tackled problems like this in 3.3 before you had the quotient rule. I would think that the best thing to do is to say that d dx of 9 over x to the 5th is the same thing as d dx of 9x to the minus 5. And now I get to use what on this?
Power rule.
Yeah, the power rule. So this would give me minus 45x to the minus 6. And then I take a step to rewrite it this way, minus 45 over x to the 6th. I think this way is a little more intuitive, but that doesn't mean that you shouldn't know how to do the other way. And if you look back up at either 6 or 7 here, I would not want to try to use some trick with the, with exponents and using the product rule instead. I think it would just be too messy. So some people try to avoid the quotient rule like the plague. I would say no. Just when you're thinking you're going to use the quotient rule, ask yourself, is there quickly a way I could write this in an easier format? Okay. That said, you are developing tools for derivatives. If I don't specify something, you're welcome to use whichever tool you want. Okay? If I ask you to find the derivative and you find the derivative using one of the appropriate rules, I'm never going to mark you wrong for not doing a certain rule. Okay? Now, remember, I will have the questions on the test that say use the limit definition to show this is the derivative, or to find the derivative. Okay? There I do want you to use specifically the route of the limit definition. Okay? All right. All right, go ahead and try number 9. Yeah. I'd like to work through this one, folks, because I'm seeing some interesting steps on your parts, and so I've misled you somehow. Let's go ahead and take the derivative of this. And normally I think it'd be fun to kind of give you 10 minutes to work it out, but we just got to keep rolling. So I'm going to follow the sequence for the quotient rule. And so that's one thing you have to do in this problem is identify, is it a product rule problem or a quotient rule problem? The big picture is that it's a quotient rule. Inside of doing the quotient rule, you will have to do a product rule. Okay? So let's just stick to the script for the quotient rule. Okay? So for the quotient rule, it says you write out the bottom. What is the bottom function here? X squared plus 1. Now here's the part where it matters. Then we're going to multiply that by the derivative of the top. Okay, so let me put, so here's the b, and then we're going to take the derivative of the top. Okay? So what is the derivative of the top? Now we're going to do a product rule.
So we do the work like upside, like on the side? Are we going to?
No, I'm just going to work it out of here. So how do I do the derivative of a product? It's the first times the derivative of the second plus the second times the derivative of the first. All of that is the derivative of the top. Okay? Okay. Minus the top function times the derivative of the bottom, which would just be 2x, all over the bottom function squared. Okay, so this was the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom square. Should we do another one of those? You guys feel okay with that?
Sure.
Do you feel okay with this, or do you need another example?
Let's do another example.
Okay. So let's do this one here. Maybe you've got some scratch paper or something. F of x is equal to 3 square root of x e to the x minus x cubed all over x squared plus e to the x. Go ahead and give that a shot. Okay, folks, I know I haven't given you enough time to get all the way through it, but let's go ahead and take a look up here. So here we go. We've got the bottom function times the derivative of the top. So for the top, for the derivative of the first term, I'm going to have to use a product rule, right? So I would have first times the derivative of the second plus the second times the derivative of the first. Now, that was my product rule. This part right here is just for the derivative of this, right? So then we take minus 3x squared, finishing out the derivative. All of this is the derivative of the top. Okay. Any questions so far? Yeah, Kevin.
Why is it only EX?
What's that?
The derivative, the second derivative, shouldn't it be EX minus 2x squared?
Oh, so I haven't taken the derivative of the bottom yet. So all I've done so far is we've got this is the bottom times the derivative of the top. I haven't done minus the top derivative of the bottom.
For the product, isn't it?
Oh.
3 root x and as the first, and EX minus x cubed as the second?
No.
No.
That would only be, yeah, great question. That would be, if I wrote that, then that would be the case.
Gotcha.
But so the whole numerator is not a product rule. It's just the first term
Gotcha.
of the that's a great question. It's just the first term. So, yeah, great. Everyone understand Kevin's question? So, unlike the last problem, where the entire numerator is a product, with this one I changed it up a little bit, and the big picture in the numerators, it's a sum or difference.
Yep.
So the first thing I started doing was taking the derivative term-wise. So that's the derivative. What I've underlined in red is the derivative of the first term, and what I've underlined in black here is the derivative of the second term.
Gotcha.
Okay. When I went to take the derivative of the first term, I had to do a product rule. Okay. All right. This, by the way, is about as hard as these get. Okay. Oops, no, I didn't finish it. Yep. So we've done the bottom derivative of the top. Now we do minus the top. And I'm going to run out of room here. I'm sorry. 3 square root of x e to the x minus x cubed times the derivative of the bottom. So I'll just write it down here. I apologize. The derivative of the bottom is 2x plus e to the x. All over the bottom function squared. All right, that was tough, folks. That was tough.